Continuing on with configurations, here are the three principles that I mentioned before. The first one, the off-bow principle, says that we have to fill the lowest energy orbitals first. So the inherent energy of those orbitals, we always have to start with the lowest when we start placing these electrons. Think of this like placing a baseball team in a hotel. So when my baseball team gets to the hotel, we're going to start putting them all in their rooms and in their suites. We're going to start with the first floor because the elevator's broken and nobody wants to use the stairs. So you always have to begin your configurations on the first ring in the s orbital. That is the lowest energy orbital you can have. Oh, my thing went away. So, have to start always at the beginning. 1s. As we continue onwards, 2s, 2p, 3s, 3p, 4s, you would think, well, 4d would energetically come next. That is not the case. 3d has a lower energy, than 4d. So after you fill the 4s, then you have to fill the 3d. This is called the off-bow series. There's this really neat picture with all kinds of arrows slanting at downward angles, but all that ever does is confuse me. I like the periodic table approach, but that's just me. So, off-bow principle says that you have to fill the lowest energy orbitals first. Second rule, Hund's rule. Hund's rule says that each orbital must be filled before moving on to the next. So, each floor of our hotel must have the maximum number of people before we can move on to the next type of suite, S, P, D, or F, or the next floor. And again, our periodic table is going to help us keep track of which orbital comes next. It's this wonderful shortcut. Last one is the Pauli exclusion principle. It says no more than 2 electrons per room in our config, which will make more sense when I show you spin diagrams. And these 2 electrons must be of opposite spins. So, just like poles of a magnet, one has a positive spin, one has a negative spin. One spins up, one spins down, for sake of explanation. So, let's get right to it. First, let's talk about the electron configuration, the roadmap to all the electrons in the hydrogen atom. If you look at our periodic table, hydrogen has 1 electron, just 1, that I need to place in this hotel. According to Aufbau's principle, I have to start on level 1, 1s. That's where I have to start. If we imagine our periodic table is blank, these are just homes to place our electrons. I have 1 electron. It goes right there. This is 1s. So, floor 1, suite S, and I am putting 1 electron in that 1s orbital. 1 electron placed. We're good. This is the electron configuration for hydrogen. Congratulations, you've just done your first. If I want to draw what's called the spin or orbital diagram, this is a picture of all of those electrons as opposed to just the letters. 1s, an s orbital we said has but 1 room in that s orbital. 1 line, 1 electron, 1 arrow. Convention says we always start with pointing the arrow up. So, that's hydrogen. Let's go on to helium. Helium, if we look at our periodic table, helium has 2 electrons. So that's 2 electrons that I am going to have to find a home for in my hotel. Off-bow principle says we have to begin at 1s. It's my lowest energy orbital. 1s, here's 1 electron in the 1s. Here's 2 electrons in the 1s. I'm out of electrons. They all have a home. So 1s, 2. 2 electrons placed in that 1s orbital. If I were to draw the spin diagram, the 1s still only has but 1 room where I can place electrons. 2 electrons. Pauli exclusion principle says I can't have more than 2 in any one blank in any one room, and they must be of opposite spins. 1 up, 1 down. The electron configuration and the spin diagram for helium. Let's add a little more complexity. Let's go on to lithium. According to my table, here's lithium, 3 electrons that I need to find a home for. So, once again, off-bow says we must begin at 1. This is the S block. So this is 1s. Here's 1 electron in the 1s. Here's 2 electrons in the 1s. So let's write that down. First floor, first row, S block, 2 electrons in the S block. Lithium had 3, so we're not finished yet. Notice I also haven't made it to lithium's box yet. Tells me I'm not finished. So 1s2, well, I ran out of real estate. I can't go any further here, so we have to wrap around to our next floor, our second floor. This is what Hund was talking about. We have to fill one level, one orbital, before I can move on to the next. My 1s is full. Now I move on to the 2. This is 2, S block. And I'm putting my last 1 electron in my S block. So now we have 1s2, 2s1 as the electron configuration for lithium. To draw the spin diagram, S orbitals have 1 room. This one has 2 electrons, opposite spins according to our buddy Pauly. My 2s suite, it's still an S, so it still only has 1 room. 1 electron in this guy, 1 arrow. Make sure as your configs start getting longer and longer, make sure it's pretty obvious which orbital belongs to which blank. Sometimes you'll see people line them up and put a little dotted line like that. Sometimes you can write the orbital name just below the blank. But let's keep going. Boron, a little more complicated with each one that we do. Boron, let's move him down just a bit there so I have more space. According to our table, boron has 5 electrons. There he is. 5 electrons that we need to place in our config. Off-bow says, got to start at 1. So, boron, 1s. Here's 1 electron in the 1s, 2 electron in the 1s, out of real estate. I have filled my 1s. On to level 2. Level 2, here's 1 electron in the 2s, here's 2 electrons in the 2s. That's 4 electrons. I'm still not finished. I haven't made it to boron's box. 5 electrons that need a home. But I have filled up the 2s. So let's add that to our config. 2s, 2. I'm still not finished. If we run our finger across the table here, I'm still on row 2. I'm still on the second floor. And the next type of suite that I run into is the P's. Remember, this was the P block. Since I'm still on the second row, I'm still on floor 2, so a big 2 still goes in the front when I'm talking about my P's. So this is 2p1, last electron that I needed to place. 5 electrons, all of which have a home. Let's draw the spin diagram. 1s, 1 room. 2 electrons, I'm going to label them below. 2s, still an S, 1 room. 2 electrons. Now for the tricky one. P, if you remember, had 3 rooms. 3 different orientations of that orbital in space. 3 rooms means 3 blanks. All 3 blanks must be present, even if you don't fill them all. You still have to draw them. Hotels don't have rooms popping in and out of existence whether or not their rooms are full. That would look kind of strange. Kind of look like Swiss cheese. But I've never seen a Swiss cheese hotel. So rooms can't vanish. They must still be drawn. This P has but 1 electron. It goes in the first blank. And there is the spin diagram for boron. Let's squeeze 1 in here real quick. Let's do potassium. Potassium, way down here, 19 electrons that I need to place. Let's see if we can read it off the table. Begin at 1, 1s1, 1s2, filled up the 1s with his 2 electrons onto the 2, 2s1, 2s2, 2 electrons in the 2s, it's full. Onwards we go. 2p, 1, 2, 3, 4, 5, 6. Remember, we're going to potassium. I filled up my 2p. Wrap around, now we're to 3, third level, 3s, 1 in the 3s, 2 in the 3s, 3s, 2, woo, still going, Across we go. Still on row 3, but now we're in the P block. 1, 2, 3, 4, 5, 6. Ran out of real estate. Filled up the P block. Wrap it around. 4s. 1. 1 electron in the 4s. To draw the spin diagram for this guy, 1s, it's an s, 1 room, 2 electrons. 2s, still an s, 1 room, 2 electrons. 2p, 3 rooms. 6 electrons, 1, 2, 3, 4, 5, 6. One thing I should mention, electrons are like kids on a hot bus. They really don't want to sit next to somebody else unless they have to. So put 1 electron in each blank, then go back and double up. On 2, the 3s, it's still an s. 1 blank, 2 electrons. 3p, 1, 2, 3, 6 electrons. 4s, 1 blank, 1 electron. So there you have it. This is the basic format for electron configurations. In the next video, I will go on to D's and F's. See you then.